everybody when it gets going. Okay, so it's the back end of the review. I will give you the timeline on how we're going to get this all done, but your test will be Tuesday. That was the question. Still a long ways away. I mean, you guys are going to be super prepared. We're still going to be a little bit ahead of Mr. Richens, but not. We're closing the gap because he's catching up as we're stalling. Not really stalling, but getting you super prepared for this test. Then you guys had better buck up and get the work done so that I don't have to have a whole bunch of you in here trying to retake it because you didn't get prepared the first time. Nobody gets a week and a half to prepare for a test in my class, but we are this time because we're letting Mr. Richens catch up. So get her done. I'll tell you all about what you should be doing in order to prepare really well. Way too short. Okay. So we are we're taking a look at problems that come from section 3.4 having to do with the quadratic formula. And before we run that through, I'm going to remind you what the actual formula is. And it says this: if you get an equation that you have to solve, a quadratic equation you have to solve, and you get it all together so that you have it in the form ax squared plus bx plus c, so that it's in order like that, and set equal to 0, whether the 0 is on the right or left makes no difference. You should always put it on the side where this is positive, makes your life simpler. If you get it arranged like that, and if it's not already, then this is the solution. The x's that you can plug in that make this true can be found by doing this. Whatever that is, the opposite of it, plus or minus that same thing squared, minus 4 parentheses. It's a good habit to do this. And then you take the front coefficient times the back one, including all signs and everything. Goes in here, all over twice the front one. That's the quadratic formula. And the other thing that we learned in this section was only 2 things, and that was how to use this, how to make this happen in several different situations to find these solutions. And the other thing we learned was about this part of it called the discriminant. I think it's spelled like that. The discriminant is that b squared minus 4ac. That's all it is, that part of it, b squared minus 4ac. Just that stuff that's circled there or boxed up there. And when you figure out what this number is, call it D for discriminant. That'll be a value. Have some number that's a value. You square the b, you subtract 4 times ac, you get a number out of it. If that number is positive, that's how we write positive in math. That means, and this is how we write that means in math, that word, that symbol means is pronounced implies. It's a verb. If this, then, or it implies that you will get 2 real solutions. And I think it's clear why. This is not something you should have to memorize. If you've got something under this radical that's positive to square root, the result's going to be real. If that junk underneath that radical, called D, is negative, then you'll be square rooting a negative to finish things up, and you'll have 2, why 2? Because of the plus minus, 2 imaginary solutions. And the only other possibility is if D is 0. Then you get 1 real solution. And the reason why it cuts it down from 2 to 1 is because if this junk under here turns out to be 0, the square root of 0 is 0, and adding and subtracting 0 does nothing. Doesn't change anything. So the plus minus has been eliminated as the producer of 2 solutions. There's only 1 solution, and it's negative b over 2a. If this stuff is 0, there's only 1, and it's real because these numbers are real. Okay. So let's practice a little bit of applying the quadratic formula and applying the discriminant, showing how things are answered and how we use things. Okay. So consider this. On section 3.4, page 127, the very first set of instructions from 5 to 18, those instructions on those exercises says solve the equation using the quadratic formula. Use a graphing calculator to check your solution, which you're welcome to do, but you won't be required to check your solution with the calculator, but you could. to verify you got the right numbers. You could graph it and find out if the decimal value is really close and equivalent, close to being equivalent to what you got with quadratic formula. But if it says use the quadratic formula to solve, then I expect to see the results in this form if the stuff under the radical won't square root. It has to be in what we call simplest radical form or exact form. So let's consider one of these. Anybody have a preference which one you want to look at? I want to do number 14. 5x squared minus 6 equals negative 4x. 5x squared, or was it negative? Negative?
Yeah, negative.
Okay. So before we can use the quadratic formula, we need to create this situation right here. And as you do that, you should always choose to make your squared term positive. So which side shall we put stuff on?
Right.
The right. And when you put it on that side, put it in order. 4x was already over there, so it keeps his sign, but the 6 has got to change because it's coming over. Okay, so now it's in that form. Now we apply the quadratic formula to find the x's. X equals the opposite of b plus or minus the square root of whatever we wrote here, we square here, and it's always positive because we're squaring. Minus 4 parentheses. Now we looked at the front and the back. That product is a positive 6 and a positive 5, and that's positive 30 over twice the front one. Anybody have any trouble with plugins? Anybody? Understand why I put everybody understand why I put things where I put them for this? Yes? Any question? So now we focus our attention inside here in the discriminant part. And there's something inside this radical. We've got a subtraction. We've also got a multiplication. You do multiplication before the subtraction. But when you multiply, you you realize that this negative belongs to that 4. So what we get is 4 plus or minus, and this is 16 minus, combined with a negative 120. What's 16 minus 120? Or better yet, what's 120 minus 16? 104, but it takes on the negative sign because there's a bigger number. So it's negative 104 over 10. That's just simplifying the radical. You got to multiply this and then combine it with this. Got a negative 120 combined with the 16 is negative 104. After that, I think it's pretty clear. I think you recognize you're going to get imaginary solutions out of this. But we have to make it as simple as possible, which means we're going to square root the negative as an I, but we're going to square the 104 by finding it's not a perfect square, so we have to find its pairs. We'll do that right over here. If I take 104 and prime factor it, it's even, so 2 will go into it 52 times. 52 is even, 2 will go into it 26 times. 26 is even, 2 will go into it 13 times, and 13 is prime, so I'm done. There's only one pair of numbers. There is a 26 left inside, since 2 times 13 is 26. So we get 4 plus or minus. This 4 right here, square root is a 2. Square root of 26, there's an I, because don't forget the negative, over 10. And I can explain this if you would like in greater detail, but here's the deal. When you get to this point right here and you've simplified the radical, if this triangle of numbers has a common factor, you need to divide it out of all of them. And so it ends up being 2, because they all have a factor of 2, plus or minus I root 26 over 5. You see where I got that? Okay, so you simplify the radical. If the numbers that are that came out and the numbers that were already out, these guys right here, this triangle of numbers, if they have the same factor, you have to divide that out, write down what's left. If in the future you should have a teacher or a professor that requires this type of number to be written in the form a plus bi, strictly in that form, then you've got one more thing to do. I don't care. This is perfect, 100%. No, nothing taken off for this. This is great. Done. I would take one off for this. You just simplify. But this is fine, but it's not of that form. To put this answer in that expected form right there, you would have to divide the 5 into the 2 and the 5 into the I root 26 as separate terms. And it looks like this, so that it's really, truly properly put in that form right there would be 2 over 5 plus or minus, that's right, this either one of those signs, and this would be the square root of 26 over 5, and you'd stick the I out here because it belongs to the entire fraction. That makes it very clear what B is. See? So if either one of these forms, perfect for 100% for me. But you may run into a teacher in the future when you do this that's going to require you to do this. I just want to show you how. That 5 can go under both of those separately. You stick the I out on the back side so that it really looks like this. Do you know what I mean? Okay. All right. Do you want to see, so this one, because of the discriminant, when we finally simplified, the B squared minus 4AC here turned out to be negative. If that all they said was find the discriminant, you would have written negative 104 by doing B squared minus 4AC. You would write negative 104. By the way, if I ask you to find the discriminant and interpret the results, this is what it will look like. Let's pretend that this was, well, it was number 14 on the exercise. So let's pretend it was 14 on the test. On the answer sheet, it will have 14 and it will say DISC, and then it'll have another blank separate from that. And if it said find the discriminant and interpret it, this is how you would answer this particular question. You would find B squared minus 4AC and you would get negative 104. So that's what you would write right here. I want you to actually find the value, the actual value of it. Not just what its sign is, but the actual value. And because it's negative, you would say 2 imaginary solutions in that blank right there. That's the interpretation. Do you see that? Okay, that is section 3.4 in a nutshell. Would you like to see another one that maybe has 2 real solutions? Or is that necessary? Do any of you want to see any other demonstration of the use of the quadratic formula or its discriminant? Okay, I hope that's enough for you people watching. Moving on to section 3.5. This all should be reminder stuff, I would think. The title to section 3.5 is Solving Nonlinear Systems. What that means is you're going to get 2 equations for each problem, and together they form a system. And whenever you're trying to solve systems of any kind, it means find the XY coordinates from this grid that are shared by both. In other words, the intersect points that are shared by both equations. That's what we're in search of here. Okay, so consider some of the things from the exercises. This should be reminders, so we should be able to work some of these out. The very first set of exercises says solve the system by graphing. Check your solutions. Okay, when it says solve the system by graphing, I'm hoping this will stay running while I'm using it over here. We mean to get your calculator out and graph them. They're telling you, not only telling you how to do it, they're giving you permission to use your calculator. So you need to go to your Y equals screen where you enter equations and clear it out. And let's do number 10. Okay, I've got a system going there. And this is what it says to take a look. You have to have your eyes on number 10 so you can see what I'm typing in here and how they are the same. I'm on page 136. If anybody's interested in looking, you should be. Number 10 says y equals 1/2 times x plus 2 squared. This is how we enter it. We start by putting a fraction in a set of parentheses. Whoops. 1/2. That's your 1/2. It needs to be in parentheses. Or you can put 0.5. That's fine. And then another parenthesis set. X plus 2. Close it squared. So that's one of the things we're going to graph. The other one's going to be y equals, so we have to put that in y2, parenthesis negative 1/2. And just so you know, I had 2 people, when they put this in with me, say, it won't graph. It's because they use their minus sign here. You need to use the negative sign. It interprets the minus sign as subtracting from something that comes before it, and there's nothing that comes before it, so the calculator's going, I don't know what to do. So make sure you use the proper horizontal little slash there. It's the negative sign at the bottom. Okay, x squared and plus 2, and it's not in parentheses. I want to talk about these before we go on, before you actually hit the graph thing. Well, this parabola, and well, I gave it away. Well, this equation right here will be a parabola. How can you tell? Yeah, the squared part here at the end. And based on this number right here is where you look for it. Will it open up or down? Will it be fat or skinny? Fat. What do you call this thing? What kind? Horizontals happen inside. Vertical shrink of a half. So somebody took the original parabola and squished it like this. That makes it wider. Yeah? Is this one going to open up or down?
Down.
Down. And it's going to be fatter or skinnier than normal?
Fatter.
How much fatter is it than this one? It isn't.
Yeah.
Same body type, right?
Yeah.
Okay. This one's going to go where? This top one. To the left too. This one's going to go where? Up to and open downward. Okay, so that's something to expect. Just that. And because this problem has no context, it's likely to fit on a standard screen. So to figure that out, if you've got a different kind of screen in your calculator, go zoom and down to standard, and it gives it to you and also plots these things. What we're looking for are places where actual points on this grid where this parabola crosses this one, and there's two of them, one here, one here. So to find those, we go second, calc, and intersect. Calc is above the trace key. And usually I find the leftmost cross point first just because it's a habit, but the spider's sitting right there, very close to this one. All you have to do is get closer to one point than the other. That one's already practically sitting on it, probably is sitting on it. I'm just going to hit enter for the first curve, enter for the second curve, and enter to find it. So one of the points of intersection is 0, 2, and you write it down like that. So if this were number, well, it is number 10. If it's number 10 on the test, and it asks you to find the points of intersection, I will always give you 2. There may be only 1, but I will always give you 2, and it'll look like that. That's what the answer blank looks like. And so you just fill these in. We've got a 0, 2 for one of them. Go find the other one because they wanted us to solve by graphing. Second, calc, and intersect. And this time I got to get the cursor closer to the other one. And then enter, enter, enter. -2, 0 is the other one, and that's what you write right here. We all right? Not too bad, right? Okay, so that's called solving by graphing. You use your calculator and find the intersect points. It's not very hard if you can put it in your calculator properly. Now I want you to take a look at the set of exercises after those graphs, and numbers 15 through 24. It says, solve the system by substitution. If you get a problem like this on the test and the instructions are solved by substitution, and you solve this and get it right, you get 1 point. You lose all the others for not following the instructions and showing me the substitution. So I want to be sure that you can do all of these different ways, these different methods. So if it says solve by substitution, this is what I expect to see somewhere on your paper to verify that you know what you're doing. Let's do number, let's do number 19. This is what it says. This is how it's presented to you. 2x squared plus 4x minus y equals -3, and -2x plus y equals -4. If you're going to do this by substitution, you got a little bit of work to do on one of them first. In order to have something to substitute, you've got to isolate a variable. You see that will be easier to isolate on this one than this one. Well, I should say easier to isolate, but easier to substitute because this one's linear. I haven't got the square to deal with. So I'm going to solve for y on this, and it's going to be y equals 2x minus 4. I just kicked that over and tucked it in there in the front. So it looks like what we're using. Then what I'm going to do is write this with a substitution. It's going to write 2x squared plus 4x minus, not y, but this. And since it's minus things with 2 terms in it, you're going to have parentheses. Equals -3. So that's this equation exactly, except for the y has been replaced with what y is equal to here. That's why we had to do that first. Because it replaced it with a 2-termer and it's a subtraction, that subtraction's got to belong to both of those. So you need parentheses for distribution. So now the trick is to solve this it's written in only one variable, so we probably have the skills to do it. So I'm gonna say 2x squared plus 4x minus 2x plus 4. And I'm gonna bring the 3 over. And the reason I'm doing that, because I recognize I'm gonna have to solve a quadratic. And when we solve quadratics, everything comes over to one side where this is positive. We set the thing equal to 0 and attempt to solve the quadratic. We got 3 different ways to do that. But I got a little more cleanup here. So I got 2x squared plus 2x in that combination plus 7. Okay? At this point, and you'll be doing this many, many times on this test and throughout this chapter, so the whole thing's about is solving quadratics. At this point, when you get to here, you've got a choice of 3 things. You can graph it and find the zeros of it. You can factor it if it will, or you can use the quadratic formula. Those are your 3 options. It's me trying to solve this, and I know I have those 3 options. I look at this for maybe no more than 10 seconds to decide if I can determine if it will factor or not. Numbers are pretty small. I got the dang 2 screwing things up in the front. That's hard to decide. A lot of people, when they see this, they don't even try to factor it because they're not very good at it. That's fine. If it doesn't factor, or you don't know if it will factor, don't spend 5 minutes trying to decide, because if you decide that it won't factor, you wasted all that time. Now you got to go another solution method anyway. So I don't know if this will factor. I got 2 other options now. I could graph it, or I could quadratic formula it. What do you think? What would you like? Do you want to graph it? Okay. Now understand what we're graphing, folks. We are not graphing the solution to a system. We are graphing the solution to the quadratic resulting in the substitution. And if right here you went graph, if you just wrote the word graph, I'd know what you did, and that's fine to use your grapher to solve this equation because the substitution's been shown. But we're solving a quadratic, not a system, just a piece of it that happens to be quadratic. So clear things out, graph that quadratic, 2x squared plus 2x plus 7. Probably it'll fit on this screen. Yep. Uh-oh. What does that mean? You could do the quadratic formula, but what kind of answers will you get? Imaginary ones. We are looking for places on that grid, which is made up of 2 real axes. We're looking for places on that grid where that parabola on the top crosses that line that's below it. That's what we're looking for. How do you interpret what we got? When we went to find the zeros of that quadratic, there aren't any real ones. What does that mean? No solution. Graphically speaking, what does it mean? It means that quadratic and that line never hit each other. They never intersect because we didn't get any real x values. You got to be able to interpret what you've got. You go to graph it to find the x values that make this tree. You find, oh, there aren't any. What does it mean? In that system, there is no solution. There is no xy combination that makes the top equation true and the bottom equation true at the same time because they never hit each other. They never share a point. Are you with me? Okay, let's do one that actually does have a solution. This is what happens if it doesn't. And let's say that this was, I can't even remember what the problem number was. Let's say it was number 16. So on the answer blank, it looks like this. It says 16 and it has these 2 things. What are you going to write? Because it offers you the 2 possibilities of crossing. And in this one, what do you write? Yes, you do. Right over the top of it. I can read through all that junk. That's what you've decided. Do not just leave it empty and say, well, there was no solution, so I didn't write anything. That doesn't tell me anything. Leaving it blank tells me you don't know what you're doing. You got to tell me what you got. Okay? All right. So let's try one that does have a solution, and let's see what that looks like. That we do with substitution. Let's see if I can find one that's going to have an actual solution. Let's do number 18. No, I don't like that one. Let's do number 15. Y equals x plus 5. And y equals x squared minus x plus 2. Okay, can you see that if you had your choice, which for this system you would do, can you see this is an excellent one for graphing? Because it's set to go. You don't have to clean up or arrange or redo anything. It's set to be graphed. But the instructions above it say solve by substitution, so now you're stuck. You have to do it that way. What that means is, since y already stands alone in both of these, you could either replace this y with this stuff, or you could replace this y with this stuff, and wouldn't it result in the same thing? Yeah, so we just have x plus 5 equals x squared minus x plus 2. That's your substitution step right there. You look at that and say, okay, I got a quadratic. How do we handle quadratics? Set them equal to 0.
X squared and positive.
X squared term be positive. So which way should we go? X squared, I got a negative x. I'm going to have to subtract that x. I'll do that in my head. That's pretty easy. 2, and then minus 5 is minus 3. Y'all clear? Okay, now at this point, you got 3 choices. You could factor it if it will. Will it? It will, and it didn't take you very long to decide. I would always consider factoring first because it's much faster. So factoring if it will, and this will. So I've already made my choice. But the other choices are, if you can't decide if it'll factor is, you could quadratic formula it, or you could graph it. I'm going to do the graphing and the factoring just to show you could do it either way. But this factors. It factors as, because the numbers are small, there's a 1 right here. Factoring's a good consideration, and this one works. Factors of 3, that subtract to be 2, or 3 and 1, they'll still a combination. And happily, they subtract to be 2, but the 3's got to be negative and the 1 positive to get that negative 2. You following? And that's equal to 0, which means if this is the one that's 0, x is what? 3. And if this is the one that's 0, x is negative 1. Now I need you to understand something. That looks for all the world like a point because it's got a comma in between, but it is not a point. What you have discovered are x coordinates of the points. What you have discovered is this, that the points where this line crosses this parabola, one of them has an x value of 3, and one of them has an x value of negative 1. This is not an x and a y value. 2 x's. And we got to figure out the y's that go with each one of them by doing what? Into what? One of these equations. Which one's obviously going to be easier? The top one. So if I let the x be 3, which is my first one up there, then what's y going to be? 8. And if I let it be negative 1, it's going to be 4. So these 2 guys are what you put in the blanks of the answer thing. There'll be 1 for each of them. Now let's say you looked at that and you're a really terrible factor, and you look at it and say, that's not going to factor, so I'm going to graph it. And then once you graph it, you go, oh, I see it was factorable now because what I got. So go back to your y equals, and let's say you get to that quadratic and you want to use your calculator to find the zeros. You go x squared, squared, minus 2x, minus 3. And we're looking for the zeros of that. Look at that. Negative 1 and 3. Let's verify. We calculate a value. I think negative 1 is a value that works, so I'm going to find out what the calculator says it is. Yep, sure enough, it's a 0. Without doing the zeroing thing, just put your suspicion in. The other one looks about like 3, but I'm not. It's kind of got a little hook thingy right there, and I'm wondering if it's a little more than 3. So I'm going to actually find the 0 on that one. Oh, it is 3, which is exactly what we got by factoring. 3 and negative 1. But those, you got to understand what you got here if you're going to use graphing to solve it. What you have got here is the x values of the points of intersection. What we have here has nothing to do with these. They don't look like either one of these. These are x values of points. You're using the calculator to graph, but it has nothing to do with the picture of those 2 things. Just the solution to this substitution equation. You see? And then you got to go back and find your y's. Okay. Do you need to see an elimination one?
I would like to see one.
Yes. Okay, so if you look at the top left corner of page 137, it says solve the system by elimination. So you have to do it the way they tell you. And if they tell you, if the instructions say solve by elimination, they have to get the two equations so that elimination will work. So you can count on that. It says solve by elimination. It's going to be something you could apply to. So let's take a look at number 34. Looks like big numbers and kind of complex. Should we do that one? Okay. So we got negative 10x squared plus y equals negative 80x plus 135. Boy, these are big numbers. 5x squared plus y equals 40x minus 85. Okay, these numbers are big. Things are not in order the way we like them. Except if they ask us to do it by elimination, everything's perfect. Everything is perfect. Because look, to do elimination, you have to have things lined. There's your x squares, there's your y's, there's your equals, there's your x's, there's your constants. Everything's lined up. It's all ready to go. Except, yes?
So 135 is a 155.
155?
Yeah.
Thank you. I heard something different in my head. It's bad. Okay. So they're all lined up, which is perfect for elimination. The problem is if I were to just draw a line and add them now, nothing would add out. But it's not very hard to prepare for it to add out. For example, if you look at the very first one, what would you have to do to one of these to get the x squares to add out? Multiply, which one? The bottom one, by 2, because that would give us a 10 here. But it had to be every term multiplied by 2. If you wanted the y's to add out, what would you have to do? Run a negative through one of them, right? So that you'd have a positive y and a negative y. What if you wanted the x's to add out? If you chose to, yeah. You'd have to multiply by 2 to get the x's to add out. But isn't that what we said that we'd get rid of these? Ooh, cool. If we multiplied this by 2, we could get rid of 2 things. That's always good. We don't want to get rid of these. We need to get rid of one of the variables, right? Okay. So we could get rid of the y's, and that would be fine. But if you notice as we went through here, if we multiplied by 2, we could get rid of the x squares and the x's. That's nice. So let's do that. If I run a 2 here, I'm going to get, if I multiply that through the entire thing, I'm going to get 10x squared plus 2y equals 80x minus 85, 90, 180, 170. Yeah. I don't need this one anymore. This is a different version of it. A nice one that's going to have things add out. So now I draw my line. I'm adding this to this. Those add out. This y plus this 2y now is 3y. Close that out. That was a good thing. 155 minus 170 is negative 15. And we divide pretty quick. So what have we discovered? This. Be careful. This is what we have discovered. But one of the points where they hit, if there's more than one, the point where they hit is y of negative 3. A y of negative 3. How do we find the x that goes with it? We're going to have to plug it into either this one or this one, which has smaller numbers without the 2, or this one. Which one would you like? The smaller numbers? Okay. So, back this up a little bit. We could plug it into this one right here. We would have 5x squared minus 3, because that's what y has become, is a negative 3.
Negative 5.
Guys need to correct me quicker. Be confident. I make mistakes all the time. Fix it. All right. So the y, the positive y up there is getting replaced with a negative 5 because that's what y is supposed to be. Equals 80x minus 170. No. Oh, boy. Glad I'm not taking this class for credit. Now do I have it right? Yeah? We good? Okay. So now what kind of a thing have we got to solve here? What is it? What do you call it? This equation is what kind of equation? Quadratic. How do we handle quadratics? Which side?
The one that makes the x squared equal.
Which is?
The left.
The left on in this case. So we have 5x squared. There's only one x term. He's coming over and changes his sign. I got a negative 5 plus 85. Right? Okay. When we get to this point, 3 choices. What are they? What's one of them? Could factor it if it will. Could graph it. Quadratic formula. Those 3. Got it? If you decided to use the quadratic formula on this, I would get rid of the 5 that's in all of these first because it cuts down the size of your numbers. And when your numbers are small, you make fewer mistakes. Do you think it will factor?
Probably. I think
It's
so.
hard to tell, but we can. Can you all see the 5 in there? That should be instinctive to yank that out. X squared minus 8x plus 16. Not only is this factorable, it's a perfect square trinomial. If you don't recognize it as that, that's fine. But look at it and ask yourself, now that this is a 1, do I know of factors of 16 that add up to 8? 4. What kind of an 8 do I want? So these are,
Negative.
there you go, got a 5 out here, equals 0. So factoring did work, it was beautiful. This will never be 0, so you can ignore it. When will this one be 0? When x is what? 4. When will this one be 0? At 4. There's only one value of x that works, and it goes with that y value. So, if this problem number was number 8, on the answer sheet, it will look like this. It will have a point here like that, and another point here like that. We only got 1 point. So put that in the first one. And you must indicate to me that you know there's not another point. I'm putting an X through that last one. Or scribbling it out. Something like that to indicate to me that you knew not to fill that one in. You didn't just not find it. You with me? Good. All right, so that is section 3.5. You okay? Any questions? Yep,
Did we go over a question using the quadratic formula?
we did. It was over here. We did a whole bunch of that over there. Were you here?
Yeah.
Oh, well, you missed it.
Okay, I just have one question.
Oh,
So when you're going to find the x values and the y values, and you have like the simplified version, do you just use to do the b?
the simplest radical form version?
Yeah.
Yeah, it's got the radical left in it. Yes, you would put that right in the blank on the answer page.
Okay, so you don't simplify it further as a calculator.
No, but I can tell you this. I'll tell you a secret since you asked the question. On all of these where you're trying to find the points of intersection, at the very, very worst, your x's and y's will be fractions or whole numbers. They will not be that garbage from the quadratic formula. Okay, they will be reasonable, rational numbers. So if you end up with one of those, better look harder because you might have done something wrong. Okay, all right. Okay, section 3.6, this one's called, the title to this is Quadratic Inequalities. Ew. Now you got to fall back to your graphing skills a little bit. We rehearsed some of those. We talked about those a minute ago. I'm going to come back to, no, I need the calculator in a minute. Okay, so quadratic inequalities, if you will look with me at the exercises, I want to help you with the decision making of the questions 3 through 6 matching. I want you to look at how you make these decisions based on what you know about quadratics. Okay, so we're doing 3 through 6 on page 144, and we're trying to match those up right there. 3 through 6, page 144. Okay, so take a look at number 3. Let's see if we can analyze what that graph is supposed to be kind of looking like and some of the details of it. Number 3 says y less than or equal to, and it's x squared plus 4x plus 3. And looking at that, if that were an equal instead of an inequality, would that parabola open up or down? Okay, then we have eliminated a. You see that? Okay. Will it be fat or skinny? Normal. As will, if you'll glance through there, just glancing through there, all 4 of those will be normal. So that's not going to be a delineator. Will the graph of it be solid or dotted? Solid. So now we've eliminated number or part B. Now we just have to ask, will we be shading in or outside that thing? Because that'll delineate C and D, because one's in and one's out. This says we want the Y values which are below. Same kind of word as less than. Yeah. Well, if it opens upward. It would be below the graph. When you graph that thing, it splits the graph up into 2 pieces. Above, an upturned parabola is inside it. Below it is down, underneath it, and all around it on the outside. So which one are you going to choose? C. Good. All right, now look at number 4. Will that open up or down? Then it's A. That's all we needed for that one. Because there's only one opening downward. So for number 5, will that open up or down? Up. Solid or dotted? Then it is B. Last one. Opens up or down? Solid or dotted? Shaded above or below? So you choose D. Did I go too fast for anyone?
But
Because D was all that was
how
left.
do you, shade it, yeah.
How do you what?
How do you tell when you shade it in or out? Again, I just forgot.
It's really above or below that you're talking about. Yeah. You read it very carefully. Look at number 6. It says, shade those Y's which are above that graph. Above and greater than are the same kind of word. You see?
Yeah, I just.
Okay.
Had to remember what somebody
Right,
did.
right. And you read it, just those Y's which do this to this graph, above or below it, and then that's where you shade. Okay, so let's take a look at 7 through 14. It says graph the inequality. So now you got to remember how to graph parabolas. Let's say we wanted to do number 12. Want to do that? Yeah, okay. Number 12 is offered to you in standard form. And in order to graph a parabola, you need to know 3 things. Try to recall what they are, because you did it last chapter. You need to know where to start counting from. That's the vertex. You need to know whether to count up or down. That's the sign on A. And you need to know how to count it. That's the size of A. That's a stretch or shrink. So, to do number, what did I say? 12. Negative 2x squared plus 9x minus 4. And it's y greater than, what's the symbol? Greater than or equal to, like that?
Yeah.
Okay. So we need to know where to start. Oh, brother, can't tell it. Or down. Down. Is it going to be fat or skinny? Vertical stretch of 2. We're going to count all of our odd numbers doubled. And not only that, because it's an inequality, will it be dotted or solid? The boundary will be solid. We got to go find this. Do you remember how? Negative b over 2a, because it's in standard form. So negative b over 2a in this case is equal to negative 9 over negative 4. Oh, gross. Well, fractions are fractions. How do we find the y value that goes with it? Plug it into here. So what I want to calculate is negative 2 times negative, oh, it's positive. Good. 9/4 squared plus 9 times 9/4 minus 4. And then if you get that written down, you know what you're plugging in. What do? Grab the calculator. Don't deal with those fractions. Go to your home screen and calculate that exactly as it's written. Don't forget the negative that you're leading off with is this negative down here. Negative 2 parenthesis 9 divided by 4, close it, squared, plus 9 parenthesis 9 divided by 4, close it, minus 4. 6.125. Math, enter, enter. Fraction is 49/8. Gross. Since the objective for you is to graph this thing, You might want to make these decimals so that you know where they are on there a little bit better. This would be 2 1/4. And this would be, as we just saw, 6.125. That's nasty. Ooh, gross. But here's how you do it. Here's how you handle it. Plot that point, now that we know where to start. Here's the origin right there. We go out 1, 2 1/4, and up 6 and a little bit. 1, 2, 3, 4, 5, 6 and a bit. Just right there. Put it in the middle of that box. Then we're going to count down, and every one of our down counts will be twice the next odd number. So I'm going to go out 1, down 2. Out 1, not 3, but 6. Here's how you can tell. Where that spot is in that box, that's where all your spots will be in their respective boxes. They'll always be in that same general location. Okay, here's your axis of symmetry. So the one that's, it'll be in this box in the very same location right there, and this one will be over in the next set of boxes kind of down here like that. We decided it would be solid, so we won't have to dot this with an eraser. Now all we have to do is decide about this. We want those y's, which are, how do you say that word? Greater than, but we're going to say here, what word? Above that graph. So we're going to be out here. And you don't have to do any more than that when you shade it. That's fine. It just gives me an idea of the 2 regions you've chosen the correct one. You don't have to spend all the time shading. I've seen people do that. Completely shade it in. Color it with a graph on it. Color it real pretty. Don't waste time like that. You got other problems to do. Okay, that was exciting. Can you see that the vertex would be much easier to find one like number 14? Much easier to find that vertex because it's in vertex form. But if you have one in standard form, like this one we just did, you're going to have to remember the negative b over 2a. You got to get this thing graphed. What else could you do to find the vertex? Graph it on this and ask for a maximum. This will tell you the same thing. You don't have to remember the negative b over 2a if you remember how to use this tool. Okay, so let's do that. Let's pretend we got that very same thing and we don't know what the vertex is because it's standard form. So we put it in the calculator. Once we get it graphed, we ask over here in the calc key what the maximum is because that's the vertex is at the highest point. Left bound, just get it closer, but stay on the left. Crawl up over the mountain, come back down the other side. Enter, enter. Voila, 2.25, 6.125. You can find your vertex that way if you want. Do you understand? You see what I'm saying? You have many options. You could even, if you didn't remember the vertex form, like on number 14, you could even graph that and ask it for the vertex. And then you look back and you go, oh yeah, I could have found that. Okay. The last thing in this section that you have to know how to do is how to use this 2-dimensional grid to answer a 1-dimensional question. And this is what people, I don't know why it is so hard to build this concept into people's minds, but it is. I'm not sure why. I'm going to try again, which means I'm going to talk slow and louder. What we're going to do is we're going to use this graphing method to solve an inequality like 35 through 42. Would you look at those with me? You have to have your eyeballs on this to understand what I'm about to say. 35 to 42 on page 145. It says, solve the inequality by graphing. What I want you to notice is in every single one of these 8 problems, there are no y's. They're all x's, which means that our values that we're going to be answering the question with will all occur on this axis. The y values are not looking for shading. We're looking for x values that make the inequality true. Just x's, but we're going to use a 2-dimensional graphing of it to answer the question. So I'm hoping I can convince you of this. So if you haven't been convinced already. So it says solve by graphing. Here's what we're going to do. Let's do number, just turn around and get too watered up. Okay, let's do number, let's do number 40. Okay, watch what I'm going to, look at number 40 and watch what I'm going to type. We're gonna type 3x squared plus 5x minus 4. Do you see why? Everybody clear? Why it's 4?
Yeah.
For number 40. We're good. Okay? So I'm going to graph that thing because that'll give me a boundary or something to look for. But it's a different use of a parabolic graph. I want you to notice what it does. Remember, we are looking for x values, just x values, that make that inequality true. I'm going to go ahead and write the inequality so I can point to it. Oh, what problem number was it? 40. Okay. 3x squared plus 5x minus 4 greater than less than 0. What is it? Plus 5x minus 4 less than 0. So we graphed this parabola. What we're looking for, you need to understand clearly what we're looking for, you're going to mess this up. There's no y in this. There's no y. And yet we graphed it on an xy grid. We use 2 dimensions to answer one-dimensional question about the x-axis number line. We want to know what values of x could I plug in right here and here so the result of doing this arithmetic will be negative. That's what that says. We want to know the x's that we could plug in here and here so that after doing this arithmetic, the result is negative. Well, if you understand what you have here, it's a very easy question to answer. Where on this number line, this x number line, does that equation have values that are negative? There's only 3 regions. There's this one, and there's this one. Which one is it?
The middle.
The middle one. And here's why. For those of you that still haven't got it, here's why. Because we're looking for negative numbers. And look, here's what the graph's telling you. If you were to plug in this number right here, which is negative 1, if you were to plug negative 1 in for x there, for the squared one, and x there, and did all the arithmetic, guess what value you would get? This one. That's what you would get. Is that a negative number? It is. So that's one of the x's that will work. If you plugged in 0 for x, look up there. If you plugged in 0, you'd get negative 4. Right there. That's the value you get by plugging 0 in. Is it a negative number? Yes. Then the x value 0 makes that true. What would happen if you plug 2 in for x? You would get this number up here somewhere because that's at 2. That's the value you get is the y that you get by hitting the graph. If you plugged in a 1, it would be about right there. That's positive. That makes that thing false. So you don't choose these numbers out here, nor do you choose these numbers back here. You choose these because the values that result from them are negative, which is what the inequality says. Do you see? This is how you answer. We've got to find those boundaries. We've got to figure out what that gap is. So we go calculate a 0 to find one of the boundary areas. I'm going to find this one first. So I'm going to go left bound. Because of the curve, it's up. This one's down. Do you remember I told you this is 0?
Yeah.
Okay, good. So one of the zeros is negative 2.257. It's this one right here. So I'm going to write that down. The other 0 is, go second calc a 0. Get over here to the other one. Stay left of it, which means below. Right is above. 0.591. Are you all in agreement that anything between these two numbers is going to work?
Yes.
This is how you write between. That x, any x that we choose must be more than this one. And at the same time, less than that one. That's how you write between. This is what you would put in the answer blank for this problem. Everybody okay? And I don't care if you round it 3 places or 2 places. As long as you're close enough for me to be convinced you found the right number, I don't care what the rounding is, unless it says so. And it won't. Okay, now let's do one that's a little different than this. Using the same idea, the same concept, that we're looking for x's. Let's do number 37. I'm gonna type, what are you gonna type in there to do number 37?
X squared plus 8x plus 7.
X squared plus 8x plus 7. Delete that 4. So typed it over. You could have cleared it before you typed. Okay. You said it was x squared plus 8x plus 7. What way was the sign pointing?
It's going to the plus side.
So
Right.
this way?
Yeah.
Greater than? Like that?
Yeah.
Okay. Greater than 0. So when we pull that over, we got the greater than 0. We're looking for x values that make positive results, right?
Yes.
Again, this parabola split this x-axis up into 3 regions. This region down here, this region right here, and this region up there. Which of those 3 regions make positive values?
Right.
To the left of this and to the right of that. Yeah, so we need to find those boundaries again. Can you see that'll factor? Into x plus 1, x plus 7. So the zeros are -7 and -1. Can I go with that without finding it? You could find it on your calculator, right? I don't want to go waste the time. That thing factors and the zeros are -7 and -1. So this is how we answer this question. The values of x which are left of -7, x's which are left of -7, also the ones that are right of -1, there's no overlap here, so we don't stick an and in between, we stick an or in there. If x is less than -7, or if x is greater than 1, this will be true. Do you see? Now, if your parabola is turned upside down because it's got a -x squared like this, and you want to know those that are negative, you're going to be in one of those or situations again, because those are negative this way and negative this way. If you want to know which ones are bigger than 0, then you would choose the one in between if the parabola is upturned. You know what I mean? Okay. That's the nuts and bolts of 3.6. Do you have any questions? Okay, you can review this video anytime. It's on my YouTube channel. Before I get off of there, though, I want to let people know that are viewing this what's going to happen with this test. Because Mr. Richens is a ways behind. I think Mr. Hill is too a little bit, but he's teaching an extended class, so that's okay. But we are going to finish the rest of this day, which is not very long, 15 minutes, working on stuff. What is required of you for an assignment that is graded is the written review I gave you before harvest. Remember that? It was all spotty all over the chapter. Remember that?
Yeah.
If you didn't get that written down, find a neighbor that's got it written down, get it written down. That's required. That has to be done on paper, and it needs to be turned in before the test to get credit, and it needs to be complete and correct. We'll go over that together if you like, maybe a little later in the week. Then I want you to spend tomorrow and the next day either working on that written review, which is required, or if you're done with that and want some more practice, I have assigned in Big Ideas Math a review set of problems and also a practice test. Neither of those is required. If you wish to prepare really well for the test, you might want to visit those 2 assignments and try a few. One word, please listen. If any of the instructions anywhere in your work that you're doing to prepare for this test, and any of the instructions say solve by completing the square, ignore that and solve with the quadratic formula. Because that's what completing the square leads to. The only time you will have to complete the square on this test is if you choose to go after those extra 10 points. It's the only place. Okay? Any problems that are required that are not extra credit will not require you to complete the square. So if you run into those instructions, just default to the quadratic formula. So you're going to spend your time this rest of this day, the next 2 days preparing with those things I have on Big Ideas Math. Friday, we're going to take an actual written practice test. It's very much like your actual test. You take it as though it were a test in class, testing situation. You're going to take that and the key home for the weekend, come back Monday, ask any last minute questions. We'll test on Tuesday for the real thing. And you should all be scoring in the 80s and 90s. It's that much preparation if you haven't wasted your time. It's not that big a deal. However, it's very, very important. So I'm glad that we are spending the extra time on this quadratic chapter. Everybody clear on what we're going to do?
Yes.
Then I'm done. Okay. All right. Hope you like that. See ya.